Hello people. Welcome back. Let's do a quick recap of the last session, before we learn more about pandas. We have learned that pandas is a wonderful and indispensable tool in the field of data science. It offers great flexibility in data exploration and processing. At its core, pandas has two data structures, the series and the data frames. A series is one-dimensional, and a data frame is two-dimensional, like a table. A series is a data frame, as a vector is to a matrix. It can handle a variety of data sources, and can write the data into different formats. Indexing and slicing are the process of selecting a subset of a data frame or a series. Indexing refers to picking out a single record, column, or cell, while slicing refers to picking out multiple records, columns, or cells. Joining and merging refer to combining two data frames along the index or a specific column. We learned the differences between the two operations and understood that merging offers better flexibility. We can concatenate two data frames along any axis, while row-wise concatenation is more common. We can compare the data in two data frames at a cellular level and obtain a detailed report on the same. Group by is a widely used operation that involves one or more of the following steps: split, apply, and combine. The data frame is split into multiple chunks, based on the key column we provide. Apply operation can be an aggregation, or a transformation, or a filtration. Combine builds a data frame from the results of the apply operation. Let us look at some examples to understand better. This is a sample data frame containing the name, alter egos, and net worth of fictional superheroes. Let us try and find the total financial worth of these people in the respective universes. When we group by the column universe and aggregate the net worth column, we get our desired results. We have the option to decide if the universe column should be an index or a column of the result data frame. You might have noticed that aggregation reduces the dimensions of the data frame. But transformation works a bit differently. It returns a series that is equal to the data frame in terms of number of records. Suppose if we want the total worth of the universe to appear side by side with individual net worth, we can use transform. Note that a new column is added, and the total for the universe is displayed. We have included only universe and net worth column in the transformation, because the others are text fields, and the sum operation just concatenates the strings. Next case, filtration. Sometimes we might want to pick only a few items from a group, based on a criterion. Here, we are going to pick the top 3 richest people in their own universes. We apply a lambda function that returns only the top 3 largest items in each group, based on the net worth column. You might have noticed that the data frame has two hierarchies of indices. The outer one, containing zeros and ones, is for the groups, and the inner ones are the indices of the records in the original data frame. This is called a multi-index, and it is supported by pandas. One important thing. If the key column contains null values, it is usually ignored as a group. But that behavior can be changed as well. We can use the drop_NA parameter and override this behavior. Notice that Zeus, who appears in both universes, has a null value in the universe column. Since the value is null in the universe column, that group is ignored by default. But when we use the drop_NA parameter, null values are also included in the grouping. Group by is a widely used operation when performing descriptive analyses to obtain sum, mean, median, or other metrics at a group level. Pivot and melt are reshaping operations. Sometimes we require the data in stacked or long format. Sometimes we require the data in a wide format. That is where pivot and melt come in. They are helpful in reshaping the data frame according to the need. When the data frame needs to be converted from long format to wide format, we use pivot or pivot table. Both are available as data frame methods and top-level functions. Let's first look at pivot. Pivot is a simpler method when the data frame has unique values on the column on which the pivot is to be performed. For example, in this case, we have the temperature data for two cities, New York and Los Angeles. The temperature is taken twice a day. If we want to convert the data to a wide format, such that the cities form the columns and the date forms the index, we can do a pivot. But as we are pivoting based on date, there are duplicate values. Pivot works if the data does not have duplicates in the index. To demonstrate pivot, we have filtered out the temperature readings at 6 a.m. only, so that the data frame does not have duplicates on the index, which is the date column. But the pivot table operation is more advanced. Not only does it handle duplicates on the index, it can perform a range of aggregation operations as well. Here we consider the same original data, but we perform a pivot table operation instead of pivot operation. We also specify the aggregation function as mean to handle the duplicates on the index. So, in the value column, we get the mean of the temperature as intended. Melting is the converse of pivoting. Like the pivot operations, this is also available as a data frame method and as a top-level function. Let's consider a small data frame containing the names of supercars and their performance metrics. The performance metrics are present as columns. This is a wide format data frame. If we want to convert this into a long format data frame, we perform a melt operation. Here, the performance metrics, which were the columns in the original data frame, have been converted to rows, based on the model of the car. The ID_vars parameter takes the index column. The var_name parameter takes in the name of the new column formed after the melt operation, that contains the metrics. We can also provide the name for the value field. There is another operation, similar to melt, called wide to long. This operation expects the columns that are to be unpivoted to have a common prefix. The other columns are left intact. In the real world, no data set is perfect. It will almost always have missing values. Hence, it becomes vital to handle the missing values before performing analyses or building a machine learning model on it. Pandas offers the options to fill a constant value, like 0, mean, or median of that series. We can also use forward fill and backward fill options. Let's see them in action. We have a dataset about supercars. They have some missing values in top speed, price, and horsepower columns. For the price column, we choose to fill the mean of the column in the place of missing values. For the horsepower column, we choose to fill the values using the forward fill method. For the top speed column, we choose to backfill the values. We also have another method, which fills the missing values, using an interpolation method. Some of the supported interpolation methods are linear, time, polynomial, quadratic, etc. Let us quickly jump to an example on this. This simple dataset has some numbers on the first column, and their multiples of 2 on the other column. The second column has some missing values. When we call the interpolate method on the second column, the missing values are filled, splitting the non-null values on either end into equally spaced regions. Pandas offers basic visualization support by integrating with Matplotlib. We cannot create advanced visuals that are interactive, but we can create decent-looking plots that are helpful in a quick analysis. We call the plot method on the data frame and pass the arguments for x and y. The default plot is a line plot. Here we are plotting a sine curve using the plot method of the data frame. However, the default plot can be changed using the kind parameter. Pandas supports lots of plot types like scatter, bar, histogram, pie, and more. Though Pandas supports visualization, the most commonly used libraries for visualization are Matplotlib and Seaborn. Let us look at them in a dedicated video. Today, We learnt about the grouping operations, their split, apply, and combine pattern, and the subsequent actions like aggregations, transformations, or filtrations. We learnt about the reshaping operations like pivot, pivot tables, and melt. Pivot can be used to reshape the data from long format to wide format. It can handle non-numeric values in the value column, but cannot handle duplicates in the index column. Pivot table can handle duplicates in the index column, but cannot handle non-numeric values in the value column, because an aggregation has to be performed. Melt is the converse of the pivoting operation, where we convert a data frame from wide format to long format. We explored the different methods of handling missing values in the dataset. Finally, we took a quick look at the basic visualization support that Pandas provides. This marks the end of this session on Pandas. I'll meet you again in another informative video. Until next time, happy learning!